Okay. Yes, thanks, John. Up next, we have another very special guest who is a native of the Netherlands and someone I had originally met in Lisbon, Portugal, late last year over our mutual love of a very, very niche NFT collection called the Bastard Gantunks version 2. His name is Rosco Callis. I don't know if I'm pronouncing your last name right, but Rosco Callis. And on Twitter, Rosco dons a particularly eye-catching and I dare say iconic avatar, a front-facing bastard with wild hair, thick neck, and 3D glasses. What those of us in the bastard community call a grail. For the chain safers in attendance today, who will be going to Dev Connect in a few weeks, Lerna, Phil, etc. Rosco would be a great connection to make, especially since he recently shared his top list of favorite restaurants in Amsterdam on Twitter. I digress. Rosco has quite an extensive portfolio in Web3, having first broke through onto the scene, writing Cash Script, a high-level smart contract language for Bitcoin Cash. He then moved on to develop AnyHedge, the first DeFi project on Bitcoin Cash. Thereafter, he spent time as an engineer for Consensus, where he expanded on the Truffle suite by creating the Truffle dashboard, as well as creating an integration between the Truffle command line tool and IPFS/Filecoin. Most notably, he became a mini celebrity in February of this year when a number of high-value NFT hacks drove attention to the importance of revoking token permissions from your address. The NFT horde by then had found and recommended Rosco's revoke.cash website, which had been presciently created 2 years ago, at least according to the GitHub source code. He now spends time as a co-founder of ChainGrep, which bills itself as a Web3 search engine and a new kind of block explorer. And without further ado, I'd like to invite Rosco onto the stage. And Rosco, you can, the floor is yours. Feel free to take it away.
Thanks for the great introduction. It's probably one of the most elaborate introductions I've ever gotten at a stage. So thank you. Yeah, let me share my screen. I think I thought for this meetup it would be, wait 1 second, it would be fun to sorry, just gonna move this to a different desktop. I thought it would be fun to repeat the talk that I gave at ETHCC earlier this year on token allowances. So let me share. Where is it? Yeah. All right. So I didn't change any slides because the content is going to stay the same. So essentially, my talk is about unlimited ERC20 allowances and why they may be harmful. So, well, I think I can skip this slide because Tim already introduced me so well. But yeah, so most importantly for the talk today, I created revoke.cash a few years ago in 2019, late 2019. And revoke.cash allows you to inspect and revoke any token allowances that you may have. So what are we going to talk about? First, a bit about what ERC20 allowances are, why unlimited allowances may be harmful, and then look at some case studies or like some cases where allowances were actually exploited. And finally, some things that we as users, but also as developers can do to mitigate those risks. And this talk is like specifically about ERC20 allowances, but the same concepts also apply to ERC721 and 1155. So it's both fungible and non-fungible tokens, as their allowances work essentially in a similar way. So first, what are ERC20 allowances? So essentially, if I have this DAI contract and Alice wants to send their DAI to Bob, then of course they can just send it directly. But with allowances, they can also grant an allowance to Bob, and then they allow Bob to pool the money to themselves at a later date. And how that works is that Alice can send can call the approve function on the token smart contract, where they give Bob an allowance, and then later on Bob can call the transfer from function, which checks that they have an allowance and then transfers the funds. Like I said, in this specific example, you might think, well, this just sounds like a very convoluted way of sending money, because Alice can also directly send it to Bob. But right now it's Alice and Bob, but it's going to be much more interesting when it's Alice and Aave or Alice and Uniswap, because with smart contract transactions, it's not actually possible to send a token directly to the smart contract and in the same transaction also execute a function. And whenever we're using smart contracts, we do want to use functions, because that's the main use of smart contracts. So in this case, if I want to deposit some DAI to Aave, I need to make sure that I have set an allowance to the Aave contract before calling the deposit function. And then the Aave smart contract calls the DAI smart contract with the transfer from function to sort of pool the funds towards the Aave smart contract and then execute any kind of logic that it needs. And the same thing goes for something like Uniswap. If I want to swap DAI for ETH, then I'll need to allow it first, allow Uniswap to take my DAI first. So if you have ever used Uniswap or basically any kind of DeFi application, I guess, you're probably pretty familiar with this concept. Like every time, for example, when you want to swap on Uniswap or want to deposit anything, you will see this sort of button here. It says allow the Uniswap protocol to use your tokens, and whenever you click that, you'll be prompted to sign and to grant the permission. And usually what these protocols do is they ask for an unlimited permission, but MetaMask also allows you to enter a custom spend limit, and some protocols also offer the choice between the limited and unlimited allowance. So one thing that may sound obvious with allowances is that when you're granting someone the access to your funds, then you are granting them access to your funds, for better or worse. So with smart contracts, of course, we know that bugs can happen and exploits can happen. And with a regular kind of smart contract exploit, the hacker will just steal the money from the smart contract. But if allowances are involved in the exploit, then the hacker can not only take the money from the smart contract, but they can also take the money that wasn't deposited in the smart contract because of these allowances. So something that people sometimes tend to do is with new kind of protocols is they will deposit only a small amount of money into the contracts, maybe not knowing that their wallet funds are also at risk, even if they only deposit a small amount. So when I started revoke.cash in 2019, this wasn't really an issue yet, mainly because DeFi wasn't really a thing yet. NFTs weren't really a thing yet. Like everything was just in its infancy. But since then, definitely more and more exploits have been seen using allowances, and One of the first bigger ones was the Bancor hack in 2020. In that case, they deployed a new version of the Bancor network, and one of the functions was accidentally set to public, which should have been an internal contract function. So what that meant is that basically anyone could call that function and take users' funds through allowances, because that's what the function did. In this case, no funds were lost because it was all white hat hacked. But we've seen plenty of other hacks. This was a big one last year. I think it was in February. For a combo was had an allowance hack where a hacker pretended to be a new version of Aave and was proved in the Fura combo smart contracts as being that new version. So then that granted the hacker essentially access to all the funds that people approved for a combo, and in this case, it was $14 million. And in these two cases, these were pretty big and established protocols or applications that were hacked due to like a vulnerability. But it's also possible for just malicious websites to take advantage of these allowances in the first place. And one interesting case that I like to talk about is the Unicats. This definitely wasn't a very big thing back then, but you know, of course, during 2020 there was a lot of food and animal themed projects popping up, most of which were not super legit. And of course, Unicats was no different. So the thing with Unicats is that you could stake your Uni tokens. This was pretty soon after the Uni airdrop, and you would receive Meow tokens in return, of course. So yeah, that turned out to be a scam, shockingly. But one of the things with Unicats is that especially in the summer of 2020, a lot of people were aware of the risks of the smart contracts they were interacting with. So a lot of people would only deposit very tiny amounts. But like I said earlier, with allowances, that doesn't really matter. So in this case, anyone that deposited any amount of Uni into this application got like their entire Uni balance drained because of these allowances. So yeah, and these three cases were a while ago, and I think that especially in the past half year or so, we've seen a lot more actually. Also with NFTs now. Yeah, we've seen the OpenSea exploits earlier this year with inactive listings that still got somehow executed because the allowance was still there and signatures weren't revoked. And then, like Tim mentioned earlier, in February there was a huge crazy exploit where nobody really knew what was happening, and in the end it turned out, I think, to be just a phishing hack or like a phishing scam, but using allowances. So I believe they got the victims to sign a message or like a partial order that then would allow them to just take any of their NFTs through OpenSea by filling the other side of the partial order. So that's pretty scary. And one other thing with allowances, that one question that I get a lot about it is, you know, I got a hardware wallet because it's safe, right? It's secure. So this can't happen to me, right? But in the case of allowances and a lot of smart contract-based scams or hacks or exploits, hardware wallets actually don't offer any protection. Because what hardware wallets do is they protect your seed phrase, so that people can't get access to that. But in the case of allowances, no one needs to get your seed phrase, because they can take the money from your wallet without having access to your actual wallet. So then we can look at a few solutions, both from the developer side and from the user side. From a developer point of view, one thing that makes a lot of sense is give the user the option between an infinite approval and a limited approval. And in this case, that's sort of for the user, that's kind of a trade-off, where if you grant infinite approval to a protocol, then that means that you don't have to send any more approval transactions, but you also have some funds at risk. Whereas if you send limited approvals, then you will have to send a new approval every time you want to deposit more money or you want to swap tokens. So it's kind of a UX versus security trade-off. And it's probably not really the developer's choice to make, and that is why it's a good idea to give users options and let the user decide what they want to do. Another option is some newer standards, such as EIP2612, which allows you to grant a permission with just a signature, so without sending a transaction. And this allows us to make a limited approval every time without spending the gas for a limited approval every time you want to do something. The drawback here is that it's a new standard, and a lot of older tokens don't have this, and so you'll always have to deal with the older tokens as well. But if you are developing a new token, it could make sense to look into this. And this is used by some newer tokens as well, like the Uniswap V2 LP tokens. So then on the user side, like I said, it's kind of a trade-off between limited and unlimited allowances, sort of security versus UX trade-off. And probably a good way to make that trade-off is by evaluating who you're giving allowances to. So if it's an established contract that is not upgradable and has been around for some time, has been audited, then it's probably finer. It's probably all right to set an unlimited allowance for a better user experience. Whereas if it's something that is new, not audited, maybe upgradable or changeable, maybe not even open source, then you probably want to be more careful with the allowances. So Uniswap, you're probably fine. Unicats, you're probably not. And then the other thing that I also alluded to earlier is that as a user, you can, like, even if the developer doesn't give you the option, MetaMask still gives you the option. So even if you can't set a limited allowance inside the UI of your application, you can always click this edit permission here and then set a custom spend limit to be like exactly how much you need for now. Or if you want to go somewhere in the middle, you can also set a spend limit that is slightly lower than unlimited, but more than what you need now, so that you have a sort of a buffer for your coming interactions. And then the final thing that you should probably also take into account is that you is revoking allowances. So any allowance that you gave will be there until you revoke it, essentially. And it's good to be aware of any of the allowances that you have given to people over the years, or to smart contracts over the years, which is why I developed revoke.cash, which is a very simple dashboard that lists all your token balances and allowances to different protocols and different applications. And it gives you the option to either revoke it completely or to update it to a different value, lower or higher, I guess. So it's a good practice to periodically look at a dashboard like revoke.cash and just remove any allowances to protocols that you don't actively use or that you don't really trust. There's some links here as well for some further reading. These slides are also on my website. I can put them in the chat here as well, so you guys can figure this out later. But if you're interested, on my website kalis.me, I wrote a pretty in-depth article about the topics that I discussed right now. So if you want to just read through that on your own time, that would be the article to read. So then, yeah, are there any questions?
Nope. Eric, I know you had a question. You want to unmute your mic and ask it yourself, or?
Yeah, sure. Yeah, I posted this question in the chat, but obviously ERC20s and 721s have been around for years and years, but we didn't really consider, I mean, people talked about it briefly, maybe in a blog post or something, but we haven't, at that time, even with Uniswap around, we didn't really see many people exploiting this approval function, or this approval vulnerability, I guess, whatever you want to call it. I was just wondering if you think, that the recent attention towards it and all of that is due to maybe just more savvy attackers on the network, or if it's I don't know, just more mainstream adoption and people who are unaware of these types of attacks, if you know what I mean.
Right. It's probably a combination of both, and I think probably the reason why a couple of years ago it wasn't being exploited, like you said, there was Uniswap and there were maybe some other apps like Maker, but I think in general there are just a lot more applications nowadays, so it's kind of bound to happen. These kinds of exploits, like any other smart contract exploit, like back in those days, there were other kinds of exploits that were in the news every now and then. And allowance exploits are just sort of a niche exploit, so they don't happen as often as just the more general exploits. But yeah, I definitely also do think that the newer people entering the space who are maybe less aware of all the risks is definitely contributes to that as well, because that just gives a bigger target for hackers to exploit, or an easier target at least. But yeah, I don't necessarily think it's because of more savvy attackers. But yeah, it's probably more due to just the bigger space in general.
Makes sense.
Aaron, you raised your hand there. Do you want to unmute your microphone and ask?
Yeah, for sure. So I just want to know can I compare with like those like a kind of practices to, you know, like when you go to a gas station, when you insert your credit card, sometimes they ask you to set a limit, right? But if you do like kind of trust the gas station, like, you know, what people did like in the past, they trust Uniswap. They maybe they have read through all of their smart contracts, they trust them, then there's no kind of attacks, like because you're aware, you know, you trust this contract. But then like nowadays it's just there's so many contracts, you cannot just trust any gas stations anymore, like any random smart contract. That maybe that's the reason why we need like a limit on it. Do you think they're comparable or?
Yeah, that's a good analogy actually. Yeah, probably like if you're somewhere in the middle of nowhere or at a gas station that you've never used, you're still probably fine with credit cards, I guess, because you can always charge back. But you maybe want to be more careful, and the same thing goes with smart contracts, minus the chargebacks. So with something like Uniswap, yeah, you're like I said, you're probably fine. Like like with Uniswap, I generally use unlimited allowances myself as well, for the convenience. But there's not a lot of smart contracts that are like that, because there's also a lot of like even in established smart contracts or in established projects, a lot of the contracts are like upgradable. So there's always room for human error in that upgrading process. Like if you change something in the future, then a new exploit might be introduced there. So you're never completely secure unless the smart contracts aren't upgradable and they're audited and have been around for a while. So but yeah, I think definitely that's the right way to look at it. Like some projects are more trusted than others.
Right.
Yeah, I mean, I don't think it's even a matter of trust though, right? It's like people trusted OpenSea, but they just simply had a bug. So maybe it's just best to not use unlimited approval unless, you know, it's like a hot wallet and you really just don't care.
Yeah, definitely. Yeah, it's a good thing you said. Like it's not just trust, because trust can be built through different processes. But something like it's a very good point. And I guess in the case of NFTs, there's also another like interesting aspect about this is that like with NFTs, you can give an unlimited allowance, or you can give an allowance for like one NFT at a time. And oftentimes people are selling like a bunch of NFTs from the same collection. So with NFTs, like it's even harder to give a limited allowance. Whereas like with fungible tokens, like it's pretty easy. You can just set, okay, I'll only want to spend 1,000 DAI right now. Whereas with OpenSea, you'll have to like send 10 transactions if you want to say, oh, I want to sell token ID 1, 2, 3 through 10. So that is still something that is, you know, kind of not the greatest thing. Yeah, still kind of shitty there, but yeah.
Right. I do have a follow-up. It's like, you know, what do you think of the design choice behind of the smart contract? I mean, like in smart contract, there is only like a one function, right? Which kind of receives ethers. You know, they could have kind of optionally make it possible for every function to receive it. What do you think of the main design? I haven't digged like into it, but I never thought of the question you brought up. Like apparently, it's very interesting. Yeah, what's your thought on it?
Yeah. So yeah, this whole approval concept was created, like you said, as a sort of alternative to the to like payable functions, because with like payable functions you can send ETH and execute code in the same transaction. but with tokens, you need to be able to do the same thing. And the solution they came up with in ERC20 was these allowances. But there are there are some other standards nowadays, like the approve and call standard, which essentially bundles these things into one transaction, where there are alternatives that might be better, but it's also very difficult to like see every angle and every possible exploit, especially back when ERC20 was made. So yeah, I think ERC20 right now, that's what we have, and that's what we can build on top of. Yeah, I mean, it's not ideal. It's not ideal, but I think like all of the other standards also have their drawbacks in different ways. So there's not really an ideal standard in that sense.
Yeah, thank you. Really, really appreciate that.
Thank you.
Great, and I think that also kind of answers like Jordan's question about what is the reason that this became a standard in the first place. I think you kind of already answered that. So if anyone else has any questions, feel free to unmute your microphone and ask away.
Yeah, I see a question from you here, Tim, in the chat.
Oh yes, yeah. Okay, so I was just gonna say, like, I'm not a sophisticated like crypto user by any means. But I've seen stuff like, if you sign messages, like that might be malicious as well. So then with like EIP2612, if you sign a message, like how would you know that it's not malicious? Especially because with signing messages, you never really know what you're actually signing. At least when I look at it, it just looks like mumbo jumbo to me.
Yeah, definitely. That's a very good question, and you're absolutely right that message signatures can be very dangerous, which is exactly what happened with most OpenSea exploits actually that we've seen in the past year, especially the one that in February, where a phishing website got people to sign a message, which then essentially allowed the exploiter to just take any of the NFTs, which is pretty scary. And this is more so an issue with sort of regular signed messages, where you just have like a bunch of hex characters and you really have no idea what you're signing. So EIP2612 uses, I think, EIP712 signatures, which has like a structured kind of data that you're signing. So that's already better than just a blob of data. So in this case, for example, you're signing this data. You're saying, okay, this is the owner, this is the spender, this is the value. And probably MetaMask can do a bit of a better job in some cases to display this data, because this can still look like a bunch of hex data, but at least it gives a bit more semantic a meaning, and so at least you know what the data represents that you're signing, and it's going to be a lot more difficult for like hackers or exploiters to use that against you, because they have to like work with the data that makes sense. Like if they're gonna if they want you to sign some data, then it's gonna clearly list what you're signing. So but yeah, like I think for like really inexperienced users, it's still an attack vector, and it's still difficult. Like, and it's kind of difficult to really find a good solution to that. Yeah.
And this problem is only going to get worse as the space grows bigger and people become more and more interested in NFTs, and it becomes really important to practice good habits with signing messages and approving like token allowances and stuff like that. So Rosco, thank you for your time. Thank you for stopping by and giving us a presentation on token allowances. Really appreciate it. I hope to see you in Amsterdam, dude.
Yeah, cool. Thanks for inviting me over, and also definitely looking forward to Amsterdam.